Yeah, hello dear students. You are once again welcome to another interesting session of core mathematics for senior high school. So we'll be looking at fractions. Under this session. Alright, so let's proceed. Okay, so let's look at the outline for this lesson. So by the end of this lesson, you should be able to understand the concept of fractions, identify the types of fractions, convert from improper fractions to mixed numbers and vice versa, distinguish between like and unlike fractions, perform basic operations with fractions, arrange fractions in ascending and descending order, understand the concept of BODMAS and apply it in solving questions, and finally demonstrate skill at solving word problems involving fractions. So these are the various objectives that we seek to achieve by the end of this lesson. Right, okay, so without much ado, shall we begin? Okay, so what is a fraction? What is a fraction? A fraction is simply a part of a whole. Okay, a part of a whole. So you can think of a fraction to be like you're having a piece of cake, right? You're having a piece of cake. Now, when you cut the cake into different slices, now each slice constitutes a fraction of the entire cake, right? So the cake becomes the whole. See, the cake, when it was first baked or when it was first presented, it came as one whole, but then you decided to cut it into different parts, right? So the different part, or each part that you cut, becomes a fraction of the entire cake, right? So that is what we simply mean by a fraction, a part of a whole. So we can think of the universe, the universe or the globe as a whole, as one whole, right? We have only one universe or only one globe, but then within the universe we have continents, right? We have continents. So you can view the continent to be part of the universe, right? So it means each continent constitutes a fraction of the entire universe. In the same vein, you can think of the countries within the continent as a fraction of the continent, right? So when we take the continent Africa, we can view, let's say, Ghana, Gambia, Nigeria, Sierra Leone, Liberia. We can view all these countries as a fraction of Africa, right? So fraction is simply a part of an entire whole, right? So in mathematical sense, let's go back to the illustration I used with the cake. So assuming the cake was cut into 4 slices, okay, now each part of the cake can be written as 1/4, right? So 1/4 becomes the fraction of the cake that is being cut, right? So you see, you're having 1/4. Now that is how we represent fractions mathematically, or that is how fractions are denoted mathematically. 1/4, right? Now this 1/4 means that there are 4 parts, or 4 parts constitutes the entire cake, but then the fraction that is taken is what? Is 1, or 1 part is taken, right? So we call the part that is taken the numerator, right? So you see, we have one number up here and another number beneath. So the number up is known as the numerator. The number up here is known as the numerator, while the number beneath is known as the denominator. Now the numerator tells us the number of parts taken, right? So assuming the cake is cut into 4 slices, and then I take 1, right? When I take 1, I'll write that as 1/4. So the 1 tells me the number of parts I've taken. and then the 4, which is the denominator, tells me the total number of parts that constitute the entire cake. Right? So assuming, let's say you gave 1 to your brother, right? You gave 1 to your brother, and then let's say you took 3. So for your brother, the fraction that you gave him was 1/4, because 1 represents the part taken. For you, it will be 3/4, right? So the numerator tells us how many parts we have taken, while the denominator tells us the total number of parts. So this is the general composition of fraction. So every fraction is made up of 2 parts, the numerator and then the denominator. I believe it's well explained. Okay, so if you have a fraction 3/7, now how do you interpret this fraction? Like we said, the numerator, the number up, tells us how many of the parts that we took, and then the one beneath, the denominator, tells us the total number of parts. So the fraction 3/7 implies that we had 7 total parts, or there were 7 parts in total, right? So we had 7 pieces, but then we took 3 out of the 7, right? So it becomes 3/7, right? So this is the general overview of fraction, right? Okay, let's proceed. Okay, so we have different types of fractions. We have some types of fractions, right? So basically we have the proper fraction, the improper fraction, and then the mixed numbers. These are the 3 main types of fractions, right? So let's look at what each one represents. So what is a proper fraction? So this is a fraction whose numerator is less than its denominator, right? So when we are talking about proper fraction, all we are saying is that when you compare the numerator, that is the number on top, to the denominator, the number beneath, the number on top is lesser, is smaller than the number beneath, right? So that is what we mean by a proper fraction. Now, why do we call such fractions proper fractions? Because like we said earlier, a fraction is a part of a whole. So it means that at least the number of parts taken must be less than the total number of parts, right? Because if it is a part of a whole, obviously it means that what you take, or the number of parts you take, must be less. For it to be a part of the whole, the number of parts you took must be less or smaller than the total number of parts. In that, after you've taken part of it, some must be left, right? So that is why we call them, that's why we call this kind of fraction the proper fractions, because that is a proper, or that is a normal way of understanding fractions, right? Yeah. So like we said, the numerator constitutes the number of parts taken, and the denominator constitutes the total number of parts. So if I have 2/3, it means that I'm having 3 parts in total, but then I took 2 out of the 3, right? And that is a proper way of viewing fractions, right? So that is what a proper fraction is. The numerator is less than the denominator. Okay, let's move on. So we have the opposite, which is the improper fraction. Now with the improper fraction, the numerator is rather greater than the denominator, right? So this is improper because, like we said, a fraction is a part of a whole. So, and we said that the denominator is represent the total number of parts. So it is abnormal for you to take more than what you have. So here we have 13/6. Now this is the denominator, this is the numerator. So the 6 is telling us that this is the total number of parts available. So how come you're able to take 13 out of 6? That is why we call it improper. It is not proper, right? Because you can't take more than what's available. You can only take out of or part of what you have, right? So it is improper, right? That is why we call such fractions improper, because the numerator is more than the denominator, meaning that the number of parts you took was greater than the number of parts available, right? And we can have a practical example of improper fraction. I think this is used in the banking field, okay, in the banking sector. We have what we call the overdraft, the bank overdraft. So with bank overdraft, it is a credit facility that enables you to withdraw more than what you have in your account, right? And it is available for current account holders, right? So if you open a current account with a bank, they have this option or this facility that helps you to withdraw or take in excess of the total balance in your account, right? So this is a typical illustration of improper fraction, right? Because the normal thing is that if you have an amount of money in the bank, you go there to withdraw part of the total balance you have in your account. If you try to withdraw more than what you have, they will tell you that you have insufficient funds. But then with the overdraft, though the amount that you are demanding exceeds the total balance in your account, you'll be allowed to withdraw it, right? So that is a typical illustration of improper fraction, right? So let's move on. I believe you are enjoying the lesson, right? Alright, so let's look at mixed numbers, right? What we popularly call the mixed fraction. The most appropriate term is mixed numbers, right? So this is a fraction expressed as a combination of a whole number part and a proper fraction. So it is a fraction expressed as a combination of a whole number part and a proper fraction, right? So mixed numbers is actually a result of improper fraction, alright? So we can only have mixed numbers when we have improper fraction. So with a mixed number, we try as much as possible to rewrite improper fractions in a different way so that it makes sense. It makes more sense, right? So we have the whole number part. So let's take this example: 2 whole number 3 over 4, right? 2 whole number 3 over 4, right? So this is a mixed fraction or a mixed numbers. So we have the whole number part, that is 2, right? So the 2 becomes the whole number, and then 3 over 4 becomes a proper fraction. So it means that when you take any improper fraction, we can break it down into a whole number part and then a proper fraction part, right? So that is what mixed numbers are. Alright, let's proceed. Okay, so like I just gave you the correlation between mixed numbers and improper fraction. So it means that we can convert between mixed numbers and improper fraction, right? We can do that kind of conversion because there is that kind of correlation, or there is a relationship that exists between mixed numbers and improper fraction, right? We derive mixed numbers from improper fractions, so we can change from mixed fractions or mixed numbers to improper fractions and vice versa, right? So let's start with how to change from mixed numbers to improper fraction, right? So to help us understand, let's take this example. So assuming we are asked to convert 3 whole number 1 over 4 to improper fraction, how do we do that? Right, so let's use this example to go through the process briefly. So the first thing to do is multiply the denominator of the proper fraction by the whole number. That is step 1. So when you take a mixed number, it is made up of 2 parts: the whole number part and the proper fraction part. In converting from the mixed to the improper, the first thing is multiply the denominator of the proper fraction by the whole number. So here our denominator here is 4, right? So we multiply 4 by 3, right? So 4 times 3, which is 12. So that is what you are seeing here, 4 by 3. That is the first step. The second step, add the product to the numerator of the proper fraction, right? So After multiplying the denominator by the whole number, you add the product, the result, to the numerator of the proper fraction, which is 1 here. So we have 4 times 3 in bracket. Afterwards, we are going to add it to 1. So 4 times 3 is what? It is 12. So what is 12 plus 1? 13, right? So afterwards, we are going to divide the total by the denominator of the proper fraction. So the total here was 13. Now the next thing is divide the total by what? By the denominator of the proper fraction, which is still 4. So our final answer becomes 13 over 4. Right. So that is how we can convert from mixed numbers to improper fraction. Now let's look at a scenario whereby the whole number part is negative. Right. So assuming we had negative 2 whole number 4 over 5, how do we change that one to? Well, generally we said that the first thing is to multiply the denominator of the proper fraction by the whole number part, right? So you would say that, oh, then I have to multiply 5 by negative 2, then I get negative 10, then I add negative 10 to 4, then I get, that is negative 6, right? So you negative 6 over 5. No, please, that is not how to go about it, right? So when the whole number part is negative, this is how to do it. Now you are going to forget about this negative sign, right? You are going to forget about this negative sign, and then you treat the whole number as a positive number, right? You treat it as a positive whole number, and then you go through the same process. So you multiply 5 by 2, not negative 2, right? So 5 times 2 is what? It is 10, right? Then you add the 10 to what? The 4, giving you 14. Then you divide it by what? By the denominator, which is 5. So the answer is going to be 14 over 5, right? That is if the 2 were positive, right? But because there was a negative sign in front, after going through the same process, you just attach a negative sign to the entire fraction, right? So in the end, you are going to get negative 14 over 5. So whenever the whole number part is negative, just forget about this negative sign, right? And go through the same processes. Afterwards, you just attach a negative sign to the entire improper fraction. I believe you get it. Okay, let's move on. Okay, let's look at the flip side of everything. So let's now move from improper to mixed, right? So let's take this example. So we have 23 over 5. So assuming we are asked to convert 23 over 5 to mixed numbers, how do we do it? So let's go through the following steps. So the first thing is find the number of times that the denominator can divide the numerator, right? And that value becomes the whole number part of the mixed fraction. So we are basically going to divide the numerator by the denominator, right? So we are going to ask ourselves, how many times will 5 go into 23? How many times will 5 divide 23? Right? Now if we get that number becomes the whole number part, right? So 5 goes into 23 4 times, right? So our whole number becomes 4, as you are seeing here, right? So the first thing you ask yourself is, how many times will the denominator go into or divide the numerator? And the answer becomes the whole number part. So here 5 goes into 23 4 times, right? Then you ask yourself, what is the remainder? So if 5 goes into 23 4 times, now what is 5 times 4? 5 times 4 is 20, right? So what is the remainder? The remainder is 3, right? So the remainder then becomes the numerator of the proper fraction part of the mixed numbers, right? So we have 4 whole number 3 over, then the denominator of the improper fraction becomes the same as the denominator of the proper fraction part. So it's simply going to be 4 whole number 3 over 5, right? So the 4 tells us the number of times 5 will divide 23, and then the 3, which is the numerator, tells us the remainder So 5 for 20. When you compare 20 to 23, the difference is 3. So the remainder becomes 3. So 3 becomes the numerator of the proper fraction part. And then you divide it by what? By the same denominator, which is 5. Alright. Now when you try to convert back, you come back to 20 over 5. So like we saw earlier, you multiply 5 by 4, which is 20, right? Then add a 20 to the 3, which is 23. Then you divide everything by 5. So 23 over 5. Right? Have you seen the correlation? Alright, so let's look at a negative improper fraction scenario. So we have negative 31 over 7. This one too, you would forget about the negative sign, right? And then assume that everything is positive. So how many times will 7 go into 31? That is 4 times. 7 4 is 28. Right? 7 4 28. Remainder, compare 28 to 31. The remainder is 3. Right? Then you divide everything by the 7 here. So you're going to get 4 whole number 3 over 7. But because there was a negative sign in front, you're going to attach a negative sign to the entire mixed fraction. I believe you get it. Yes, so that is how to convert from improper fractions to mixed numbers. Okay, let's move on. Alright, let's look at operations of fractions. And by operations, I mean addition, subtraction, multiplication, and division. Right? So how do we add, how do we subtract, multiply, and divide fractions? So that's what we are about to look at right now. So let's start with the addition and subtraction of fractions, right? But then before we look at how to add and subtract fractions, let's take a look at two categories of fractions. So when you take any fraction, or let me say when you have a group of fractions, we can classify them into two different categories, right? So we have what we call the like fractions, and the unlike fractions. Now, like fractions, these are two or more fractions which have the same denominator, right? So let's take this example here. So 1 over 5, 2 over 5. Now these two fractions are said to be like fractions. Why? They have the same denominator of 5, right? So we use the similarity of their denominators to tell that they are like fractions. Right? They are like fractions. So let me give you this scenario. You see, you can, in some instances you can tell whether a group of people are siblings or they are brothers and sisters based on the similarity in their surnames, right? Good. So assuming one person is called Bismarck Asari, and then another person is called Vivian Asari, Comfort Asari, there is that tendency that they are siblings because they bear the same, or they bear the same surname, or they bear the same last name, right? It is the same with fractions. So because they bear the same denominators, right, we say they are like fractions. It could be that their numerators are different, right? So we had Bismarck Asari, Vivian Asari, Comfort Asari. They had different first names, but then they had the same last names, right? Yeah, so it is the same with like fractions. They may have different numerators, but then so long as they have the same denominators, they are said to be like fractions, right? Now, unlike fractions, so these are fractions with different denominators, right? So you have 4 over 3, 1 over 2, 5 over 7, 2 over 9. They have different denominators, right? So if you have a number of people with different surnames, there is that tendency that they are not related, right? They are not siblings in any way, right? Yeah, so that is what unlike fractions are. Now, our understanding of these two categories of fractions will help us in adding or subtracting fractions, right? So the way we add or subtract like fractions differs from the way we add or subtract unlike fractions. right? So let's look at the addition and subtraction of like fractions. So when we are dealing with like fractions, how do we add and how do we subtract? So basically with like fractions, it is simple. Because they have the same denominators, we just add or subtract their numerators. That is all. So let's take this example here. So assuming we are adding 1/5 to 2/5. Now because they have the same denominators, we just add their numerators. That is all. So we just add 1 to 2. So we have 1 plus 2 all over 5, giving us 3/5. Right. So whenever the denominators are the same, we just maintain the same denominator and then add their numerators, just as you are seeing over here. Right. So that is very simple. So this is addition. So let's say you have 5/7 minus 3/7. So because they have the same denominator of 7, you just subtract their numerators. So it's going to be 5 minus 3, right, which will give you 2/7. Right. So that is how we add or subtract like fractions. Now what if the fractions are unlike? How do we do it? So to help us understand, let's look at this example. So we are to solve 4/3 minus 1/2. Right. Now the first thing is to find the LCM of the denominators. Right. So we are going to find the LCM, the least common multiple. The least common multiple. Now the reason why we have to find the LCM is so that we give these two denominators a common base, or let's say we give these two fractions a common denominator, a common standard. Right. So the LCM of 3 and 2 is 6. Right. So we find the LCM. Right. Now the next thing is we divide the LCM by each denominator. So we ask ourselves, how many times will 3 go into 6? How many times will 3 divide 6? That is 2. And then we multiply the quotient by each corresponding numerator. So what this means is that when you pick this 3, okay, you would ask yourself, how many times will 3 go into 6 or divide 6? That is 2 times, right? Then you multiply the 2 by the numerator, which is 4. So you're going to get 2 times 4. Alright, good. You do same for this one too. So when you come to the 2, you ask yourself, how many times will 2 divide 6? That is 3 times. You multiply that 3 by the numerator, which is 1. Right? So we have 2 times 4, which is 8, and then 3 by 1, which is 3. And then you are going to what? You are going to now subtract the numerators up here. So what we have done is that we have given this fraction, these two fractions, a common denominator. A common denominator. That is 6. And then we have given, or we have assigned new numerators to them as well. So we now have 8 for 4/3 and then 3 for 1/2. Now what this means is that when you pick 4/3, we can rewrite the 4/3 as 8/6, and you can rewrite 1/2 as 3/6. Now when you simplify them, you are going to get the same things. So you have 8/6. If I ask you to punch 8/6 on your calculator, it will reduce it to 4/3. When I ask you to punch 3/6 on your calculator, it will reduce it to 1/2. Right, so that is the rationale behind it. But then we want to give it a common denominator so that we can easily add or subtract their new numerators. Right, so we now have 8 minus 3. So the next thing is just subtract. Right, so what is 8 minus 3? That is 5. So it becomes 5/6. Right, so that is how we add or we subtract unlike fractions. So you first find the LCM of the denominators, and then you ask yourself, how many times will the denominator divide the LCM? Right, so here 3 into 6 is 2. 2 by 4, 8. 2 into 6, 3. 3 by 1, 3. Then you subtract. So you get 5/6. Right, I believe it's simple. Alright, let's proceed. Okay, so let's now talk about multiplication of fractions. So if you are multiplying 2 or more fractions, how do you go about it, right? So let's take this example. So assuming you are told to multiply a over b times c over d, how do you go about it? So basically you are going to multiply the numerators and then multiply the denominators. That is all. You are going to multiply the numerators and then multiply the denominators. So here you are going to have a times c all over b times d, right? So here with this fraction, our numerator is a. With the second fraction, our numerator is c. So we are going to match the numerators and we are going to match the denominators, right? So a will multiply the c, b will multiply the d. So we are just pairing them. Right? So that is how we basically multiply fractions. So you multiply the numerators and divide everything by the product of the denominators. Now, with multiplication of fractions, one thing that we have to take note is that, you see, whenever we are writing fractions, we are supposed to reduce them to their simplest form as much as possible, right? So in examinations, you'll be required to leave your answer in the simplest form, right? So that is one thing that we have to take note of. So whenever you are given a set of fractions to multiply, we can do what we call the self-simplification, right? That is when you check the numerator and you check the denominator and see whether you can reduce it further, right? So let's take this fraction for instance. If you have 10 over 15, now you ask yourself, can I reduce this fraction further to its simplest form, right? Yeah, you can. So assuming you are told to multiply 10 over 15 by another fraction, you don't just multiply the numerator 10 by the other numerator and then 15 by the other denominator. No, the first thing you have to ask yourself is, can I simplify this fraction before you can think of multiplying the numerators and then multiplying the denominators, right? So when you have 10 over 15, yes, you can simplify, right? So 5 goes into 10 2 times. The same 5 goes into 15 3 times. So we can simplify 10 over 15 and then we'll get 2 over 3. So it is necessary that you do this self-simplification before you think of multiplying it with the other fraction. I believe you are getting it. Yeah. We also have what we call the cross simplification, right? So this is another form of simplifying fractions before you even multiply. Alright. So with cross simplification, we compare the numerator of the first fraction to the denominator of the other fraction, and then we also compare the denominator of the first to the numerator of the second. So it goes in that kind of cross format, right? So when you pick this first fraction, the numerator is 24. So with cross simplification, we compare the numerator here to the denominator down here, and we compare the denominator down here to the numerator up here, right? So we ask we find out whether we can cancel out or we can simplify these two numbers, right? So between 24 and 6, can we simplify? Yes. So 6 goes into 24 how many times? 4 times. 6 4 24. So 6 divides itself 1, it divides 24 4 times, right? And then 7 divides itself 1, it divides 21 3 times, right? So assuming you are told to multiply this fraction, before you even think of multiplying the numerators and multiplying the denominators, you have to what? Cross simplify. You have to do some cross simplification, right? So when we do that, we are going to arrive at 4 over 3 times 1 over 1, right? Afterwards, you can then go by this format. So you multiply the numerator by the numerator up here. So 4 by 1 is what? Is 4. And then denominator by denominator. So 3 times 1 is what? Is 3. So your final answer gives you 4 over 3. Alright? Okay, so that is multiplication of fraction. Okay, let's proceed. Alright, so to our last operation, division. Alright, so assuming you are dividing a over b by c over d, how do you go about it? Now, we don't have a straightforward method of dividing fractions. Okay, so what we do is that we employ what we call the reciprocal approach. So we are going to focus on the fraction that comes after the division sign. I'm going to focus on this fraction, the fraction that comes after the division sign. Alright. Now, what you are going to do is you are going to turn it upside down. Okay, you're going to turn it upside down. So you are going to interchange the positions of the numerator and then the denominator. Alright. Afterwards, you are going to change the division to multiplication. Alright. So it means that you are going to have a over b times, you are going to interchange the position d over c. After the moment we change this fraction, or we turn it upside down, the division sign changes to the multiplication sign, right? And then we apply the rules and the multiplication of fractions to it to solve it. Right. So first you can think of doing some self-simplification or cross-simplification before you multiply the numerator by the numerator, and then you multiply the denominator by the denominator here. I believe you get me. So let's pick another example here. So we have 5 over 6 divided by 2 over 3. So like we said, interchange the position of the numerator and denominator here. So turn it upside down and then change this to multiplication. So we're going to have 5 over 6 times 3 over 2. So the 3 comes up, the 2 comes down, right? And then we are going to do some simplification here, right? So 3 can divide 6, right? So 3 divided itself 1, divide 6 2 times. So we are left with 1 here, we are left with 2 here. So we are going to now multiply the 5 by the 1 and then 2 by 2. So that is what you are seeing here. So 5 times 1 is what? It is 5. 2 times 2 gives us 4. So that becomes our final answer. So division always ends in multiplication. Division of fraction always ends in multiplication, but only after you have turned the fraction that comes after the division sign upside down. I believe it's well understood.